Alright. Let's see. 500, 807.
Cap. You wanna fight? You wanna fight? Choose me, weather. Choose me, weather.
Well, hello.
I got cheese, hose,
See it.
and a bunch of fucking. I need some killers and dumb.
Alright. So we are on page something. Page 119? Sound about right?
Yes, sir.
Alright. Have it out. Get the points for it. Love it. Dim lights. Alright. Page 119. A Las Vegas casino. Ooh. Wonders if the dice they are using for a gambling game are really producing a 6 on 1/6 of the die rolls. That is 16.67% rate. The casino has reason to believe that the die is producing 6s at a higher rate. They roll the dice 1,000 times, which results in 174 6s, using an alpha value of 0.1. Is there strong statistical evidence to say these die are producing 6s more than 16.67% of the time? Okay, so first red flag, they just rolled the dice 1,000 times and just collected the data. It was not randomly sampling. They just kind of took it all together. Hello.
How's it going? Well, good to see you, brother.
So, we have a sample of 1,000 rolls.
Hey, good to see you, brother.
Oh, you followed me.
Alright,
You did.
so
I'm kind of under the.
our null and our alternative. They're null because people are winning our dice equals 16.67% of the time. And our alternative dice, because they think it's happening more, is this way, so it's one tail. Okay, 1,000 times, they get 174 6s, so they happen to roll 1,000 times, so the sample mean comes to 17.4%, because 174 out of 1,000 is 0.174, which is 17.4%. And, oh, they're doing an alpha of 0.10. So alpha is going to go in place of our p-value. 90% confidence interval. Very good. Love it. Okay. So, let's figure out our standard error. Hello. Good to see ya. Standard error is the 17.4, right? Oh, you know what we have to do on standard error here is this. It has to be this.
T minus
Hey, good to see you, brother. We're on page 119, everybody. All right, so let's take a look. So we're going to do 0.174, 1 minus 0.174 divided by the 1,000, and Desmos should handle this nicely. So big square root.
Sister, up and left my pencil in the car again.
Do you want me to get you a pencil?
Yeah.
I got you. There, sir. Yes, sir.
Right now.
Alright, so this is gonna be 0.74, or, I'm sorry, I was off, 0.174. Times 1 minus 0.174, close parentheses, go down, divided by the 1,000 rolls. So standard error here of 0.012. So standard error is 0.012. What's that? 1.2%, exactly. Which is 1.2%.
Probably Jake Paul in Texas.
Oh, he's good. Look at this, bro. Look at this. The stats.
Alright,
Oh, he's gonna die.
let's see.
He's
What
gonna
else
die.
we have?
He's
Look
gonna
at the
die.
stats.
We're gonna
It's a
do
good
a
fight.
T-distribution based on this.
Stats,
But let me see who
KOs.
knows.
Stay on
You're
that
saying
for a
like
little.
44 knockouts?
Yeah, but
Right
he's had
there?
way less fights.
Yeah.
Well, yeah, obviously.
Nah, I think Jake Paul's might be.
No, he's not. In no way is he gonna win. I was watching videos.
It's rigged.
So basically,
What's
this,
that box?
He'll rig
Like,
it.
what sign is it?
Yeah, I know.
this alpha,
He'll rig it.
that's the probability we make a type 1 error.
He's winning Jake Paul for life.
But I'm staying, bro. He's gonna win.
Is it Jake Paul?
He's not
Dude,
gonna
he's
win.
good, bro.
I was watching Mike Tyson train,
He is pretty good.
and he's gonna kill him.
He's Jake Paul. I just think.
Based on the stats of how many fights Jake Paul's had, he's good, bro. That's a good fight.
Dude, he's gonna get knocked out.
I think he just has to tire Mike Tyson.
Huh?
He just tire Mike Tyson. And just hit him.
So this is basically where that 17.4% is
Mike
coming in.
Tyson's gonna win.
Alright, so that's basically what our normal distribution
He's
looks.
gonna
I didn't add
kill
1.2, I just showed it here, added it, or subtracted it.
He's
Alright, ready?
Tyson.
Yeah, but Jake Paul is less.
So, I'm gonna do a T distribution.
Having so little, like, he's so good.
But he is taller too. So it's
T
easy.
distribution, 1,000 rolls, degrees of freedom, 999.
Yeah,
Alright, so let me make that a little
Mike Tyson's
darker.
gonna kill him.
Alright,
Put money on it.
so
Ooh.
we're going, because this is revolving around
How much you
zero,
wanna
I'm just
put
gonna
on it?
take the,
Throw 100.
I'll throw
the
100.
1.2, plug it in.
Better, bro.
So I wanna go 1.2 or bigger.
Do your research before you make your bet, bud.
Alright,
Okay.
so we come up with a p-value of 0.115. So our t-value, which is the same as our p-value, of 0.115.
All his money.
Okay,
You said that last time.
we wanted an alpha of
The
this.
last bet?
Is 0.10 bigger or smaller
I'm not
than
gonna watch
0.115? Okay,
I'm
so,
not gonna watch it.
so this is larger. So this is a fail to reject our null hypothesis. Did not find strong evidence. Against H naught. Okay, so it was just coincidental that they happened to roll a die 1,000 times in that 17.4% of the time versus 16.67% of the time took place. Okay, so the casino must be happy. It might say, you want to know what Vegas usually does when they have a really hot person rolling the dice or playing cards and they can't verify if there's cheating?
They kick them out.
No, they usually say, hey, we have a show, we have front row seats for you to go see this concert, so you can get them away from the table. They don't want the hot streak coming on. Oh, hey, we have a nice dinner for you. I kid you not, it's real silly how they work. But all right, page 120 says an online retailer knows that 8% of the items that they sell will get returned. The company changes several policies and wonders if the percentage of returned items will change as a result. From a random sample of 200 items sold, only 10 are returned. Does the sample provide evidence on the return rate. Alright, so,
So what?
our null and our alternative,
What does that mean?
our return
What is it?
is equal to 8%,
Oh.
and our return is less than 8%, is our alternative. Alright. So 10 out of 200 are returned, so that is 0.05% are return. So 5% are return now. So was the store on to something by changing their policy, or was this coincidental? Well, let's find out. So we have null and alternative, 8% returned. And I don't have a standard deviation at all, do I? Okay. So this is the mean of the sample. Let's see, can I do this? This probably can't be done. The reason it can't be done is I don't have a standard deviation of all. I mean, I guess I guess we could use this. We could use the 0.05 here, find the standard error. So 0.05, 1 minus 0.05 divided by our sample of 200. Yeah, we could do the standard error, that works. So, standard error. .05, 1 minus 0.05 divided by 200. So standard error comes out to 0.015, which is a 1.5%. So we could do our normal distribution, 8%, 9.5%, 10%, or 11%, excuse me. Write a little neater, and I would be better. 12.5, 6.5%, 5%, and 3.5%. And so they're claiming this, so 5% or lower. Okay. They didn't give us alpha, so we went over less than 0.05, so let's figure out our p-value, or this will be our t-value actually in this case. And we should be able to do that pretty easily. Alright, t-distribution. We had a sample of 200, degrees of freedom is 199. And we want to figure out 1.5 or less. So 0.93. This is larger.
Fail to reject.
So another fail to reject our null hypothesis. Did not find evidence needed against the null. Cool. That's what we got. So, friends, let me be honest with me. Be really honest with me. If we have a snow day tomorrow, raise your hand if you plan on being here on Friday if they have school Friday.
We have a snow day tomorrow?
If We have a snow day tomorrow, but we don't on Friday.
Oh, yeah, no, I'm not coming.
I'm not coming up for
I'm not
that
gonna be
either.
here,
I just want to make sure. I'm just trying to plan. Thanks for being honest.
bro.
No, I don't blame you. I don't blame you.
It's not gonna happen.
So